Yeah, thank you. On behalf of IE and our college, now I request Dr. Tavi Venkateswaran. Because of his participation, this webinar is a unique one. Here, the social scientists are joined hands with a pure scientist who is working in a Department of Science and Technology for a long time and serving for science communication for a long time in Tamil, English, Hindi, Malayalam, in so many languages. He is one of the best communicator in India. After this COVID-19 outbreak, from the first wave onwards, he has delivered hundreds of lectures in both Hindi, English, as well as Tamil, and if possible, Malayalam, Telugu, and all that. And he is writing continuously on this virus in very particularly Tamil and English. He is the founder editor of Science India Science Wire, online science and technology news channel, which is run by the Department of Science and Technology. And for past 4 years, he is working with Rajya Sabha TV on science issues in the name of Eureka Science Conversation. And then, I think since he is from Tamil Nadu, he became a scientist in DST Vinyan Prasad. Tamil Nadu has utilized his service in many ways, so that in all leading Tamil dailies, both in English and Tamil, weekly magazines, monthly magazines, everyone at least one time it carry out his science communicating message or article or a story. He has written more than 50 books, and this has been translated in many languages, including Hindi, Malayalam, and Kannada, and all that. And now he is the best communicator in this COVID-19 virus vaccination way, with simple examples how to communicate science for non-science people. In this way, he is an expert. So that when we basically coined this webinar based on his special lecture, our president, Honorable Malgotra and Madan sir, immediately accepted. When we say that the scientist Dr. T.V. Venkateswaran is going to join with us in this session, means they immediately accepted for this webinar. This is a best occasion. I request Dr. Tavi Venkateswaran sir to deliver his special address. Thank you.
Thank you, Dr. Bani. I hope I'm audible. And
yes, audible.
Yeah, Dr. V.K. Malhotra, Dr. D.K. Madan, and Dr. R. Venkatachalam, and colleagues who spoke in this seminar before me, Dr. Muthuraja, Dr. Kanwalijit, and Dr. J.S. Desai, and also to Dr. Pari. Many thanks, and also to Dr. Shankar Subramaniam, principal of this college, for this wonderful opportunity, and all the members who have joined this session. I sincerely thank you. I believe vaccine hesitancy is one of the important challenges today in India. And if we want to end this pandemic with less loss of lives, then vaccine is the only route that we have today, only credible route that we have today. Let me share my presentation and please permit me to make my talk. I suppose you are able to see my screen, right?
Yeah. Yes, sir.
Yeah, thank you.
So
So, are you able to see my screen now? I mean, is the slides changed?
Not yet.
yeah.
Yeah. Yes.
Changed, right? Okay.
Yes. Please.
So what you see here is the electron microscope image of the novel coronavirus. Okay, I mean, you can see that it looks like a Karela. I mean, when you slice a Karela, I mean, the shape that you would see, that's what it looks like. The spikes that you see are what is called as the spike protein, which is one of the important component of this virus. I mean, from a virology point of view, we focus on this spike protein because it is through that spike protein that this virus is able to enter into our human body. This coronavirus is the 7th coronavirus that is affecting human as far as we know. We already know 6. We have found one in 1962, we have found one in 1965, we have found 2 in 2004, and one in 2003, one in 2012, and the last one, the 7th in 2019. So this belongs to the family of coronavirus. And because it's a new one that we have detected, we call it as novel coronavirus. Novel meaning the new. Okay, in that sense. The technical name is SARS-CoV-2. Okay, I mean, of the 7, the 4 are low pathogenic, meaning that even if they infect us, it won't cause any damage. At the best, you might have a sneeze or a cold or a headache or a viral fever. That's all. It's not life-threatening. But whereas the 3 of them are highly pathogenic, SARS-CoV-1, MERS-CoV, and then the recent one, SARS-CoV-2. These are highly pathogenic and can be even fatal, I mean, as we know very clearly. This is the very simple structure of the virus. I'm not going to elaborate all these things. I suppose many of us would have seen it in many news programs. But the simple structure has just about 5 parts, only 5 components. There is a small piece of RNA, and there are 4 proteins, like spike protein, membrane protein, envelope protein, and nucleic capsid protein. And along with that, it has some small amount of lipid. I mean, the lipid acts like a cover. Okay, I mean, it's like acts like a wrapper around this virus, and that's it. The size of this virus is about 100 nanometers. What does it mean? It means that suppose if I enlarge my one strand of hair, okay, I take one hair and enlarge it as big as a cricket stadium, and in the middle of the cricket stadium, suppose if we keep our mobile phone, that would be the proportion between one strand of hair and virus. I mean, quite obviously, it's very, very, very small, very microscopic. That's very clear. If we collect all the novel coronavirus in the world, okay, I mean, crores and crores of people are affected, so they will have millions of virus in their bodies. We collect all of them, okay? We weigh them. It's less than 1 kilogram. That is the total weight of novel coronavirus all over the world put together is less than 1 kilogram. Okay, that's it. Yeah, I mean, these things we know, so I'm not going to elaborate that if we inhale roughly about 280 virus particle, I mean, that's a threshold level. If we inhale roughly about 280 particle, then we have a 50% chance of getting infected. If you are keeping about 6 feet away, the possibility of inhaling about 260 virus particle will reduce very, very low. I mean, 99.9% you will not be able to inhale. So it gives you protection. And this also, we know that even if you get infected for the first 5 days, you don't get any symptom. The symptom starts around 5 days, after 5 days. But during those 5 days, you are happily transmitting virus to your friends, family, and neighbors. Okay, whoever is coming next to you. These things we know, so I'm not going to elaborate on it. This one I want to say a bit more. The way the virus enters is the virus, after it goes through your nose or mouth, it goes into the respiratory tract. In the respiratory tract, there are cells, human cells, on the lining. Okay, I mean, on the portion where our skin or the inside of our nose or inside of our lungs, meets the air. Okay, in that lining cells have a technical name called epithelial cells. That doesn't matter. I mean, basically, it means that cells which are outside lining our respiratory passage. Okay, these cells have a very special receptor called ACE2 receptor. Okay, these receptors are very important for control of blood pressure. And this novel coronavirus spike protein has an affinity to that receptor. So basically, if the spike protein touches that receptor, they both bind together. So that's how attachment takes place. The virus attaches itself to one of the cells in our airway path, okay, in our respiratory path. Once it attaches into the airway path, then the second part is penetration. Basically, it enters into the cell. This takes about 10 minutes. Okay, it's not a very simple process. A cell is a very, very minute object. A virus is even a much minute object. Please remember, even then, it takes about 10 minutes for it to enter. Once it enters, it takes away its coat. I mean, as I told you, I mean, it has a cover, right? A lipid cover with a membrane protein, enveloped protein. So they all disintegrate. Okay, so the RNA, the genome inside the virus is seed into the our cell. Once it is in our cell, the next part that it does is that it uses our cell's tools to make copies of itself. So the purpose of virus entering our cell from the point of view of virus is to make its children, its progeny. The virus cannot reproduce outside human cell. Okay, it can reproduce only within human cell, as far as we know as of now, SARS-CoV. Okay, so inside human cell, what it does is it makes copies of its RNA, it makes copies of its proteins, and then all these copies are assembled, and then the virus comes out of that particular infected cell. This process of after penetration, uncoating, biosynthesis, assembly, the virus release, all this takes about 10 hours after the infection. That is why immediately after infection, you don't feel anything. Okay. After 10 hours, from one single cell, infected by one single cell, 1,000 copies will come out. Not 1 to 1,000 copies. The virus will give birth to 1,000 copies of itself. This is the electron microscope image of that virus coming out of an infected cell. Okay, so it comes out like this. All these orange, yellowish substances are virus. The remaining are all cell structures. Okay, cell surface structures, human cell surface structures. So what you see is that the virus is coming out. So now imagine that you are now infected by one virus, let's say. Within 10 hours, now you have about 1,000 virus in your body. Of course, all the 1,000 virus will not be able to infect the nearby cells. Roughly about 50%, that is 500 will infect the nearby cell. And the remaining 500, because it's epithelial cell, will mix with your air. So when you start speaking or breathing, the virus will come out after 10 hours. Now, 500 cells are infected. Now what will happen after 10 hours? From each of these 500, now you are going to have 1,000. So which means 5 lakhs. Which essentially means that after 20 hours, you are going to have 2,50,000 of your cell infected. So that is why suddenly you feel after 20 hours that something is wrong. Maybe your throat is itching. Okay. Now after 10 hours, that's going to become 25 lakhs. Right. So numbers will keep on increasing like this. More and more cells will get affected. And that's how the virus enters our lungs within few days. Once it enters our lungs, it goes into air sacs. Okay, the air sacs will look something like this, like small balloons. Okay, and the wall of this air sac will have lots of capillary blood beds. Okay, lots of blood vessels will be there, and this is where, for example, the oxygen in the air goes into the blood, and then carbon dioxide from the blood comes into the air. Okay, so this is how the ventilation takes place. Here you can see the epithelial cells. Okay, the cells which are in the lining. Okay, so these are all infected now. Because these cells are infected in the lining, the lungs cannot function. Lung cells are dying because of this infection. Once a cell gives birth to about 1,000 copies of the virus, the cell will commit suicide, or the cell will face what's called a self-death. Okay, so the infected cell will die after about 10 hours. All infected cells will die after about 10 hours. So after first 10, 10 hours, maybe one cell is dead. But after second 10 hours, you will have about 250,000 cells being dead. And after third 10 hours, that is after 30 hours, you will have about 25 lakh cells dead, right? So imagine, that's a kind of, I'm giving a very rough estimate. That won't be the exact number in everyone, okay? But roughly that's a kind of order that we are talking about. Once so many cells are dead in our lungs, and perhaps maybe the virus has also entered our bloodstream. Once it enters our bloodstream, it can go to the heart, it can go to your kidney, it can go to your gut, it can go to different organs in our body. Once it enters your blood, well, you are critical, right? You are in ICU of a hospital. You need a ventilator, you need assisted oxygen, and all these things. That's what essentially happens. But then our body is not a silent spectator to this ravage. In our body, there are three immune systems. This is what confuses most people, because most times scientists would say in immune system, they mean the third immune system. They don't mean the first one, they don't mean the second one. But when ordinary people talk about immune system, or when people say that let's eat so and so food for immune boosting, okay, that immune boosting is essentially can boost at the best level 1, maybe a little bit level 2, okay, not the level 3 at all. Once I give an explanation, you will understand. But the scientists, whenever they talk about immune, they talk only about third. So it's a confusion of word, okay. So what is this level 1 immune system? It's barrier. For example, our skin. Suppose if I take a spoonful of novel coronavirus and put it on your skin, the coronavirus cannot infect you. Okay, skin is a barrier. Skin will protect against lot of viruses and bacteria. Only very few fungi can actually even infect the skin. Okay, most of the bacteria and virus cannot infect our skin. It cannot even get through your skin. Okay, so skin is a barrier. Like that, there are many other barriers. For example, mucus is a barrier. There are many things. Okay, so let's not get into that, but that's one. The second is what is called as innate immune system. Basically, some chemicals in our body which will inhibit the bacteria and viruses. Okay, they are called as pages and cytokines and so on and so forth. Okay, well, when we talk about a viral disease, we don't talk about the first one or the second one. The third one is the most important thing when we talk about a disease caused by a germ. This is called as adaptive immune system. So whenever a scientist says immune system, a scientist means this adaptive immune system. Okay. Whenever public talk about boosting your immune system, they talk about level 1. Maybe you get a shiny skin and so on and so forth by eating certain food. Okay. So that's completely different. So what is this adaptive immune system? That's what I'm going to spend next few minutes. Just like, for example, if you have observed me in the video, or even if you do it right now, you can very clearly see that I have a long nose. Okay. Some of you might have a curly hair. Okay. Some of you might have a long ear. Okay. Each of us have some specific facial feature or body feature which are very specific to us. Similarly, all viruses or germs have some surface feature which are very specific to that particular class of or family or species of virus or bacteria. And that is called as antigen. Okay, this word, of course, you would have heard about it in the pandemic communication. Quite a lot of people would have talked about it. So basically, antigen means a surface structure created by a protein of that particular virus. Okay. Then we have antibody. Antibody is something that our body produces, your body, my body, even animals' body, they produce, okay, which binds to this special structure. So basically, it's like you can imagine this antigen is like a nut and antibody is like a spanner. Okay. So you have to have the right kind of spanner, not big, not small, not a different shaped one. It has to be correctly shaped, correctly size. Then the spanner will fit the nut, right? In the same way, if you have the right antibody, then it will fit the antigen. And this right antibody is what technically people will always talk about, neutralizing antibody. They'll say that whether the neutralizing antibody is produced or not. Okay, that's what it is. So if there is a car mechanic, that car mechanic would be repairing, servicing different kinds of car, right? I mean, there may be Ambassador, there may be Fiat, there may be Maruti, there may be a BMW, there may be Audi. Okay, so the mechanic would have tools for all of them, right? The same way, there are various kinds of nuts, so you need various kinds of spanners. In the same way, every virus, okay, if you have let's say measles virus, the antibody for the measles virus is different. If you have got a common cold, let's say about a month ago, most likely it is by some virus. Okay, the antibody for that particular virus very, very different from the measles virus. Okay, our body, your body, my body, okay, we carry about 25 million to billion different T cells. What is this T cell? I will explain later, but it's a kind of antibody we can imagine at this point of time. We don't technically call it as antibody, but let's keep it. There is 25 million type. I'm not talking about numbers. So in the spanner, there is spanner number 14, there is spanner number 18, there is spanner number 20, there is square spanner, there is a round spanner, right? In that sense, different, 25 million to billion. And our body also has about 10 billion different B cells. That's technically called as antibodies. 10 billion, imagine. So it's like a car mechanic having a catch of spanners for different kinds of nuts. Okay. But suppose if that car mechanic shop receives a car with this car, which let's say Rolls Royce, which that mechanic has never seen in his life, and assume that Rolls Royce has a nut like this, and none of the spanners that the mechanic has would fit this nut, right? So the mechanic is now helpless. That's exactly what happens when a very new virus, a virus which has emerged very recently, evolved very recently, hits humanity. None of us have this antibody in our body. Okay, we don't have that spanner. Okay, so what does a mechanic do? The mechanic will send his boy to the nearest shop. Maybe you will get it. Maybe in the street, some shop will have it. Maybe you'll have to go to a distant part of your city. Maybe you'll have to go to the nearby city. Maybe you'll have to order through Amazon and wait for the spanner to come, right? That's exactly what happens when you are infected with a new virus. Maybe your body is able to produce this antibody very fast. Maybe the level of infection is so low that you are able to manage. Okay, that's how the diseases differ. What actually happens is the antibody mostly are like this Y shape. The hands of this antibody can change, can modify. Okay, so slowly the antibody hand modifies. It's called as affinity maturation. When it meets a new virus or a new germ, okay, and the right kind of antibody is produced. Okay, once you have the right kind of spanner, then the game is won, right? So that's what our body do. So if you look at what happens, the virus, then you are cured. You say tata bye bye to the hospital. You come back home, right? You are happy. Everyone is happy. What actually happens this whole period is like a tug of war. Your virus has infected you. You have an antibody, but it has no affinity. It is not having a right kind of affinity to your antigen. So the virus has a field day. Okay, the hand of the virus is strengthened. Okay, the virus keeps producing. Slowly, your body is producing a low affinity antigen. Okay, but by the time, if the number of virus in your body is low, maybe because you are infected very low in the beginning to begin with, or your body was not permitting the virus to multiply that fast, various reasons can come in. Then even with the low affinity, you might be able to beat the virus. So that's how most people come out of this disease without becoming very serious. Okay, but then not all case. Okay, so then finally, the high affinity antigen is produced, and it is produced in enough numbers to capture all the virus, then the tug of war, our body is in the winning side. Okay, so this is what actually happens. So the viral response is very high in the beginning, and as the maturity of the antibody goes up, the viral response goes down. Our host response is starting from the beginning, it is going up. Okay, in this, how the tug of war plays decides whether you get out of the COVID without any disease, or whether you get your disease very serious, whether you are becoming critically ill, or whether you die. Okay, it all depends on how the tug of war goes. So ultimately, anyone who comes out of COVID infection has come out because of the body was able to produce the right kind of antibody. So what about the drugs? What about the treatment the doctors give? The drugs and the treatment the doctors give are essentially to keep you alive till you produce the antibody. Your body has to produce the antibody. I mean, except the plasma treatment. I'm not going to come into that right now. Okay, your body has to produce the antibody. Even in plasma treatment, after they give it, your body has to produce if you have to get out of it. Okay, that is important. So ultimately, if you are coming out of the disease and not dying out of it, it's because your body has been able to produce the right kind of antibody, or at least the near right kind of antibody. Not for all the right kind of antibody will come. Some people who are had only mild infection, even with let's say partially fitting antibody, they might be able to get away with. Okay, so this is what happens in our body. We all are talked about variants. So a quick word about variants. Just like, say, for example, you have your parents, and your parents have their parents. So, there is a family tree that you can build. In the same way, the virus also mutates. Remember that the one generation of virus is 10 hours. Okay. In 10 hours, the virus produces its babies. Okay. In 20 hours, you have second generation. In 30 hours, you have third generation in your body. So if you look at the world, I mean, there would have been millions of generation by now. Okay. So natural evolution is common. So virus also evolves. So you have different variants emerging. Okay. What I'm showing you here is like a family tree of that emerging coronavirus. Okay. So we give them some fine, interesting names like a B2, B2.6, B1. We are very fond of giving that kind of names. So we give that kind of very funny names. So this is, for example, the emergence of the virus in a very simply put fashion. There is some progenitor. We don't know. We know that the earliest infection in China took place about a few weeks before the first case was identified. Okay. Then there was a new variant that emerged in India, and there are new variants which are emerged in different countries. Okay. These are all that we know. So this variant, what does it mean? I want to clarify. For example, the same actor can come in different guise. Okay. But it's the same actor. So all the variants that we see are like this different guys. But these are all different actors. Okay. So when this guy becomes a different actor, then it will be a new species. So currently, largely all the vaccines work because as of now, this actor has become only this different guys. This actor has not changed into some other actor. Okay, that's what is a current scenario. And then also, like engine will have multiple nuts. A particular virus will also have different antigen, not just one. So your body will be able to at least catch one of those antigen and then kill it, even if one place changes. Okay, so that's what happens. I'll not go into this technical details. These are all technical details. I told you about T cell and B cell. It's very important to know. T cells actually identify infected cells. When the virus is sitting inside a cell, that cell is identified by the T cell, and then that cell is neutralized. I mean, eliminated. Okay, along with the virus, so that new virus won't come out. B cell release what is called as antibodies, and these antibodies go in search of virus between cells, what is called as intercellular space. Like, say, for example, your bloodstream, or there are various kinds of liquids which are there between our cells in our body. Okay, so in that liquid, these antibodies roam around and then scout for this virus and then kill it. Okay, so you need to eliminate virus which is hiding inside a cell. You need to eliminate virus which is roaming around outside the cell. That's how the T cell and B cell reaction takes place. Both are adaptive. Both are like spanner which has to exactly fit this virus. So whatever you eat, whatever you don't eat, whatever you do, whatever you don't do, that's not going to make big difference in how these evolve. Of course, when I say eating, that you have to be healthy. So which means that you have to be eating what is called as a proportional food. That is, you should have adequate amount of protein, adequate amount of various nutrients, etc. You should not be hungry. You should not be a poor person lacking nutrition. Okay. Other than that, whether eating this will help, whether eating that will help, is not going to make any change in terms of this adaptiveness, because this happens inside our body. So a vaccine, what is a vaccine? Basically, what we do is that we cut one part of this virus. I mean, in COVID case, I mean, mostly it is the spike protein, because that's an important protein with which it enters our body, as I told you earlier. So we cut this spike protein and then show it to our immune system. Basically, you are introducing it to our body by injection. That's called vaccine. Once our immune system sees this spike protein, it doesn't know that it's only protein. Okay, it will start reacting and start producing the right fitting antibody. So it's basically like when a new car is introduced into the market. Suppose the car company sends out a package to every mechanic saying that this new car has this particular nut which is very, very new, and this is a spanner for it. Okay, so when the new car comes to the mechanic is ready. The mechanic need not send his boy to the nearest shop or wait order in Amazon. The person has a spanner in his hand ready, right? Or her hand ready. You can open up the car, right? In the same way, when the vaccines work, it produces antibodies in our body, which are rightly fitting this particular protein, spike protein, with regard to COVID vaccine. Okay. So what is called as a new, then it also elicits the B cell and T cell response. Once it elicits, then what happens is that when you are giving vaccine, the antibody production takes place, and then there is a little bit of antibody. Please remember that I told you that you have about 100 billion B cell and about 25 million T cell in our body, right? So this will add one more. Like the mechanic, once he buys a new spanner, that will be one more spanner in his catch, right? In the same way, this antibody will be in our body as extra. But when we are really exposed to the virus, our antibody reaction will take place immediately. So the tug of war, we will be winning from the day one. Okay, from the day zero or time zero, we will be winning, or not time zero, maybe very close to that. I mean, we will be winning. Okay, so what does it mean? It means even after vaccination, you can possibly get infected, but you will not get the disease. That's the whole important point. That is, you will not get disease. You will not become serious that you have to be admitted into ICU. You will not die. Okay, so that's what happens in a vaccine. This is, I think, a figure that you would have seen. This is a normal lungs. This is a lung infected by COVID. Somebody was recovered. Okay, even after recovery, your lungs are perforated. Okay, so that's a big challenge. I'm going to wind up now with two comments. If about, the current vaccine efficacies are around 80%. Okay, so what does it mean? If 5 people receive vaccine, about 4 will be protected and 1 will not be protected. And you have no way of finding which one will be protected and which one will not be protected when you are giving vaccination in a mass way. Okay, theoretically, there is a way to find out whether you are protected by vaccine or not, but for that you'll have to spend lakhs of rupees, okay, and painstaking research. That's not practically possible. I mean, it's not like a blood test you can just do on the roadside. Okay, so practically speaking, that you cannot find even after vaccination whether you are protected or not. That is why scientists advise that even after vaccination, please follow pandemic protocol. Okay, that's number one. And because, this is what the figure is, that is April 20th, we have about 0.04, what is called as a breakthrough infection. Breakthrough infection means infection that we have detected in people who have been administered vaccine, 2 doses of vaccine. Okay, roughly about 0.04 is in India. Covishield, Covaxin, roughly the same. Okay. And this is the important part that I wanted to stop with, is that the reason that many of us are saying, many of our scientists are saying that vaccination for some is vaccination for none, is essentially because efficacy is only about 80%. If you vaccinate a very large population in a country, then you get indirect benefit. Suppose, for example, I am vaccinated and actually I am not getting the benefit out of vaccine. But assume that my family is vaccinated. Assume that the grocer that I'm visiting is vaccinated. The vegetable vendor that I go and buy vegetable is vaccinated. The auto driver whom I use is vaccinated. Okay. So essentially meaning that almost all people that I'm going to meet in my daily life are largely, the chance that they are vaccinated are going to be high. So which means that the virus cannot come to me from them. So even if the vaccine is not working for me, I am protected. Okay. So that is why you need vaccination in large scale. Vaccinating one person and thinking that, oh, I am protected is a false belief. Please remember this, because you have only about 80% chance that you are protected. Okay. You can have a much confident of saying that I am 99% protected only when huge population is vaccinated. And with that, I'll stop my initial talk. I'm sorry if I have taken longer time. I didn't keep the timing. I thought somebody will keep timing. I suppose I did not take too much of your time. Thank you. I'll be open to questions, comments. And, thank you.
Thank you. Thank you, Dr. TVV, sir. Really, it is an eye-opening session for everyone, those who are participating in this webinar. Because this part of webinar may be edited, and it can be shared on behalf of IEA throughout India for the purpose of vaccination and to understand what is COVID-19 and how it works in the body and how we can able to control, how we can able to through our hesitations. This is a brief break for Dr. Tavi Venkateswaran sir. And now this is the session for our president. And after our president's lecture, special address, we can have interaction session on Dr. TV Venkateswaran's lecture. Now I request our President, Honorable President Dr. Malhotra sir, to deliver his final remarks and the presidential address. Before that, I wish to make a brief introduction, though our president need not any special introduction, since he is our he is father of
Dr. Mani. Dr. Mani.
Yes, sir. Yes, sir.
Can I make a request? I think this is sufficient, and I'll just begin. I don't want any more lines to be read about me.
Oh, okay, okay. Thank you, Professor. Thank you. Thank you. Thank you. Thank you.
All right.
Good evening, sir.
So good evening. So thank you, Dr. Mani, for accepting my request not to be too elaborate on my personal achievements and my curriculum vitae, in fact. So thank you for that. And my thanks also go to the management of the college, ERODE Arts and Science College, Tamil Nadu. I think in this college we have conducted a number of events, IEA, and all those events have been fantastically successful. So definitely Dr. Mani, the principal of the college, Dr. R. Sankara Subramaniam, and I was going through that there is a director also, Dr. R. Venkatchalam. So they all need to be complimented on this occasion. And my special thanks to Dr. T.V. Venkateshwaram also, scientist from DST, who has definitely given a marvelous lecture on this occasion, explaining to the students of economics how a virus reproduces itself, multiplies itself, enters into our body, and then tries to, let's say, affect our bodies in different ways, and how the system within the body reacts to that situation and fights with it. Of course, in days to come, since Dr. Mani has already made a request, and I was reading from the chat box also, that number of participants have requested that this lecture be shared with them so that they can thoroughly study this lecture and they can understand. Still, maybe still graver part of the things that Dr. Venkateshwaran wanted to discuss, and understanding it fully well, that since these are students of economics and not of biology, so they will understand the generalities of the issue rather than the too much nitty-gritty of the issues. So thank you for keeping your lecture so simple, so lucid, and so easily understandable also. It definitely, as president of the association, it gives me another way to look at the situation that I'm very happy to share with all IEA friends here. I can name them, I can see some smiling faces, and IEA people have always been smiling despite odds and challenges. So that definitely makes the whole scene much better. And I know Professor Venkateshwaran would agree that a smile in your life and your acceptance of the challenges definitely gives you still more immunity than you could crave for. All right. So IEA through this lecture has made a new beginning in one more sense, that we have been concentrating on issues of economics. But through this lecture, IEA has entered the fray of multidisciplinarity, interdisciplinarity, and transdisciplinarity, which is going to be the hallmark of the new education policy and the new researchers in the country in days to come. We all understand it pretty well that this country has been divided into silos of academics and research. They have been substantially broken on this evening. I do not know, and I could see also that number of participants have already left, at least 8 have left. I was looking at the statistics of participants. It was stable at 100 level for a pretty long period of time. In the beginning itself, I received a message that after 100, you have to join 15 minutes before we start formally with the webinar, because after 100, we would stop further entry. So the statistics was pretty stable at 100 for a very long period of time. But I can see that 7-8 people have now left. But yes, talking about the content part, I've already commented on the interdisciplinarity or the multidisciplinarity dimension of this webinar. But I see my friends from IEA, be that Professor Arunachalam, Professor Muthuraja, Dr. Kamaljeet Kaur, or Dr. Jayesh Desai, all have come very, very prepared, and they have spoken on different aspects of the whole issue. And I know my very, very dear friend and very energetic secretary of the association, Dr. D.K. Madan, definitely introduces the whole organization, because he today is not just the one who is introducing a topic. I know the way he lives IEA, and he has been living IEA for several years. So introduction coming from him of IEA is a very, very simple thing, because it is as just almost tips. So apart from all these things, and Dr. Mani also spoke about who specializes in which area of the science of economics. personally speaking, despite the fact I talked to Dr. Mani and Dr. Madan also, that I may not be available for all 2 hours that you are planning this webinar for. But in fact, I have heard each and every word that you spoke about, whether I was on a screen or not. So personally speaking, on a very personal note, I can concentrate more when I'm not on the screen. So I hope you would forgive me for that. And yes, I mean, I was listening to it, and I do feel that perhaps Dr. Jayesh comes with science background, and that is why he spoke about the different types of vaccines also, whether RNA-based or inactivated vaccines or protein-based vaccines. So he was speaking about all those vaccines. There are a number of vaccines we know in the world, and I will very quickly sum it up as my concluding comments, coming with whatever understanding I have of the subject. So there are a number of vaccines which have international approvals. There are many vaccines which have approvals in our country. There is a different protocol. The vaccines which have already received WHO's approval anywhere in the world, they would be readily approved in India also for our purposes, including emergency purposes. I need not take the names of those vaccines. Largely speaking, there are 13 very popular vaccines right now in the world. And I was reading about it. The nasal spray as a new vaccine or drug which is being talked about is perhaps going to be in days to come a big game changer in this respect. And I think Dr. Venkateshwaran can speak better than me because I'm not a medical expert. I can visualize a situation from the perspective of a student of economics, somewhere a student from the perspective of a student of management, and one who can look into the logistics of the whole issue. And this entire pandemic has opened our thinking in several ways. I see good combinations. There is no family in India, at least I have come across, which apart from taking allopathic drugs has not used some traditional medicine at home. One, to protect itself against the virus, and secondly, even if somebody in the family has developed, then also as a medicine to develop immunity to fight against the virus. In allopathic drugs also, a number of medicines, as Dr. Venkateshwaran has very rightly pointed out, they just keep us alive to fight the virus under various circumstances. So whether we talk of remdesivir or Fabiflu or steroid, the surprising part is that whatever patients, I mean, I was listening from a number of people, fans and relatives also, and I was looking at their prescriptions. Some of those prescriptions were referred to people, doctors in United States and Canada and Britain also. I remember the kind of prescriptions that we got from them, they were virtually the same we were having in India. There was hardly any difference, meaning thereby there is an assumption, famous assumption in India, knowledge travels very fast and it travels freely also. So there was a case of knowledge traveling fast and freely also all across the world. And we were definitely beneficiaries of all that. We can go back to the initial days, distancing, social distancing or physical distancing, mask and hand hygiene. And Dr. Venkateshwaran has cautioned us all that despite having 2 doses of the vaccine also, you are still supposed to use it all until the entire population of the country stands protected. So in the initial phases, I have at number of places, wherever I have spoken, I've talked about this issue, that in the first wave, people were stigmatized to some extent. In the second wave, there is more of a trauma attached to the whole issue. But good part is that the whole country is now at least seems to be moving in a direction that we are coming out of the second wave. I'm sure that we have learned number of things. So distancing, mask, hand hygiene, isolation, in which hours and when. Quarantining, I remember that I was perhaps one of the few first ones to talk about how isolation and quarantining, other than in a public hospital, should be taking place. So public hospitals, private hospitals, our experiences have been many. New facilities, how hospital can be set up in 30 days, 25 days, how ventilators can be manufactured in the shortest period of time. These are new learnings out of this whole situation. And I've been repeatedly saying, it was definitely a disaster that we were in and we were facing. How to face such disaster? What should be our response? How prepared should we be? And I think Dr. Venkatesan wanted to comment on plasma therapy also, though he avoided that finally. But I would have definitely loved to listen that response, because I have read myself number of case studies from Kerala. I'm making a mention about that, where people have given their own, shared their own experience. I know experiences of 2-3 friends of mine who went through plasma therapy themselves, and their lives, it seems, were saved finally. So with a success rate of 1%, 2%, or 5%, or 10%, I'm not entering into that kind of a debate. And the whole idea of black marketing through plasma therapy, that became a managerial issue to take it out of the COVID protocols, in fact. So we have been discussing virus mutations also these days, transmittability, seasonality, and effectiveness. I remember in the first way we were talking that when temperature in India reaches 27 degrees, the virus will get killed its own self. Now we have this experience virus in both the situations, whether we talk of wave 1 or wave 2. In both the cases, virus perhaps replicated itself more in, let's say, hot season or hotter season than during the winter season. At least in India's case. I'm not trying to attribute that to be the sole reason behind the replication of the virus in the country. I have a whole lot of statistics which I don't intend to share, but there are good things. The only thing that I intend to talk about through that statistics is that we need to grow as a reasonable society. Perhaps our concern for India as a reasonable society remains still unfulfilled. I will say, anybody can stand up and can start talking like anything unscientific. This cannot be the approach of a society which is looking forward to be one of the best leaders in the world. We know that in US, 302 million doses have been administered so far, at an average of 9.96 lakh doses per day. If I talk of US population itself, it should from now itself, if we take an average of 2 doses per person, it should be from now itself, it should be taking minimum 400 days to get completed. That's one. Israel is said to be the only country, but when I look at the WHO's website, I see that in case of Israel also, the degree of vaccination is in the range of 62 to 65%. I remember initial, Professor Venkatesan can vouch for that. In the initial researches at the global level, it came out, if 70% of the population stands vaccinated, we will believe that largely the countries stand vaccinated. But that thesis or that assumption is no longer being, in fact, furthered at this stage. If I talk of China, only 27% of Chinese population which had the first dose in the world, which has an experience of a greater experience by minimum 4 months ahead of the world. I will not enter into the debate who did it and why did it happen. I'm not talking in terms of whether Indian virus, Chinese virus, or UK virus. The point is, who has how much time and what has a country done? So China has so far vaccinated 27% of its population. European Union stands at nearly 30%. So advancement of the country, India with 231 million doses as on date, aspires to get completed major vaccination by 31st December. And to me personally, it seems to be a plausible condition, because by 31st December 2021, India would have definitely procured 216 crore doses. So if we reduce it to 50% of it and take 2-3% margin for wastages also, then substantial part of the population would definitely stand vaccinated. And if we go by the theory of 70% population getting vaccinated first, because within that, there are a number of questions. I'll just, for our understanding of all of us, I'll just cite those questions which are being raised. Which vaccine is more effective and which has less side effects? I remember why people's first choice in India became Covaxin. I will not elaborate on that. So these have been the questions in mind. To whom should the vaccine be administered? For which age group of the population? And Jayesh very rightly referred to demographic aspects. So which age group should it go first and why? Right. So there are a number of issues before a nation. But again, we say we are a young country, but about 18 to 44 population. Right. So the good part is that I understand the finance minister made an allocation of 35,000 crore. And be very clear, all 35,000 crore are not made available on the first day of the year itself. So we have to understand, as a student of economics also, we have to understand those realities. We have to give space to the things to happen. I was listening to a debate and very good questions that how long will a vaccine be effective? I think Dr. Venkateshwaran can better answer that question. Is it 3 months, 6 months? America is now considering a situation that in a year's time, how many doses shall be administered and what kind of doses shall those be? So the whole world is definitely toying with various ideas. We are in the middle of a problem. In the middle of a problem, your study is not complete. You are experimenting with few ideas also. Let's keep those things in our mind. So shall we have to have repeated doses of vaccine? That's another question before us. I remember a number of people were asking, since now second dose of Covishield has been extended from 4 weeks to initially 8 weeks, then 8 weeks to 12 weeks, and now to even 16 weeks. Right. And if somebody doesn't have within those 16 weeks also, what's going to happen to the first efficacy of the first dose itself? And so is the issue related to Covaxin also. But basic thing on which we should be definitely laying our emphasis is that we should all get vaccinated. Whichever populations are being permitted or whichever age groups are being permitted, we should definitely get those age groups vaccinated. Secondly, there came an important question, something which is not being supported by the government. Should they go pay out of pocket and get vaccinated or not? Such questions have emerged before all of us, and they are all related to our psychology also in some way, to policymakers. Sometimes we term those issues as equity-related issues. Sometimes we say production-related issues. Sometimes we do say logistics-related issues like distribution, etc. So good that the country is learning in the process. Good that the government of the country has been responsible so far and is becoming still more responsible. I give you one stunning statistics. I was looking at it. India's confirmed cases of the total world's confirmed cases are exactly 17% as on date, which is almost equal to our share of population in the world. the death in India are9% of the total deaths in the world. That means less than 50% of what is justified by our share in population. And if I go to third statistics, I talk about the active cases. Our share as on date is 2.6% of the total number of active cases in the world. So look, the way we have been performing so far. Yes, there are miles to go before we sleep on this score. That's true. But at the same time, as I said, substantial amount of logic, substantial amount of knowledge has already been generated. I said that we are in the middle of the crisis. We are responding to a disaster. We are experiencing it. And we are somewhere learning by doing also, or learning by facing also. So let's be honest with the things. Since new knowledge on COVID crisis and COVID pandemic has yet to be created, and this knowledge has to be created in a manner which would remain confirmed for all times to come. I remember when I prepared a note for discussion of the cabinet and our own ministry also, how much preparation I had to do and how did the note go. But this is where we are. We are talking of knowledge creation, which is not yet perfect and complete. Right. So the solutions cannot be expected to be complete in the middle of the crisis also. I said that we are definitely attaining a higher stage of, let's say, optimum understanding and optimum utilization of whatever remedy we have. So we are moving in that direction. I'm very, very hopeful that so far India has behaved and performed like a relatively sensible society. I feel we shall behave still to be more sensible than what we have been. Whatever our concerns are, which emanate from our anxieties of different nature, they would definitely be, I would say, managed by us at our own level, so that it is not that anxiety results into still more complexity attached to the problem. It reduces our problem rather than it aggravates our problem. With these words, I will stop here itself. I'm sure it has been a fantastic session for all of us. At least I personally have learned a lot, despite the fact I shouldered the burden or the onus of chairing the session. I stand as first learner here, and all of you have been great teachers to me. Thank you very much.
Thank you, sir. Thank you very much. As a great leader, as a part of our EA, you have summarized all the lectures, and also you are very sharply with your perspective on COVID-19, and you really, it's a wonderful consolidation and wonderful